Hello, I'm going to talk about our simulation case. Uh, we wanted to investigate the difference between HVAC and HVDC. First of all, it was a big problem to find reliable numbers for capacitance and inductance in the submarine environment. So it changed the goal changed a bit to a comparison between HVAC and HVDC. First of all, I want to start with HVAC, 132 kilovolts. The simulation has been done in MATLAB Simulink. That's a simulation model for different kind of simulations. And so this is the first model. Here you can see the swing bus with 1 pu. That means the voltage level is at 1 per unit. Also the bus bar here. That means the voltage at this bus bar is 132 kilovolts. Then we have here a symmetric load, just as a more practical orientated case. And here is the solver configuration. Every Simulink model needs such a configuration. It describes how it is solved. So you can choose time or frequency and time. This is important because it depends on which solver you take, the results will be different. And then we have here two bus bars. Two bus bars. And here is the PV bus. That means it's a production bus. And this PV bus generates 200 megawatts and has a voltage level from 1.025 per unit. So it's a little bit higher than here, and it needs to be higher because we want the power flow from here to here, and so consequently the voltage needs to be here higher. Then there are two measurement units and of course the transmission line. For the parameters, literature research has been done, especially for the transmission line and for the power generation. It was the wind farms in UK was investigated. So in UK there is a strongly growing wind power capacitance, and so this was the wind farms in UK was analyzed, and it's based on this literature review. The power was taken as 200 megawatts and the transmission line as 20 kilometers. But the more and more wind farm which occurs, the higher the power will be and the longer the transmission line is. But I will talk about this a little bit later. So here in this case, with 132 kilovolts, you have an efficiency of 99.3% of the real power. It seems a bit a high efficiency, but the transmission line is just 20 kilometers and the voltage is very high. So we have more or less low current, and we have just a short transmission line. And here, these are the values which are go into and come out. So this is always 1, and then 2, and then 3. So here will be 3. That means it's this load here. And so here on the port 1, you can see minus 200 megawatts. That means it goes from this direction to this direction. And you have minus 90.5 megavars. Here, that means 108.6 goes into the grid, and the rest goes into the symmetric load. And yeah, but more important is here the second one. That means that almost 200 megawatts come into this bus bar, and the difference are the losses. And you can see here the megavars. And it's interesting that you need such a high reactive power for this transmission line, because the transmission line is also based on the reactive power which is transferred, and so the thickness of the wire has to be bigger if you also transfer reactive power. So then in the second case, there was 64 kilovolts. That was just to investigate how the model reacts and to make some conclusions. As expected, the efficiency in the lower voltage will be lower because the current will be higher. And you can see here the megavars are much, much lower, which are needed. This is caused because the capacitance is based on the voltage which is applied, and because we have we have a lower voltage, there less reactive power is needed. Yeah, so it's still the same transmission line length. It was expected that the efficiency will be lower. Here, another important or noticeable thing is that the phase angle, the phase shift is higher compared to the other one. With 132 kilovolts, there are like 1.8 degree, and here it's 6.76 degrees. So to the next one. So first of all, there is a big problem with the simulation of HVDC. Maybe I will start with this one here just shortly. So this model was tried to do a HVDC simulation, but this doesn't work. So I will come to it later. But there was also investigated some test cases, and the problem with the test cases is there are much more in detail, and because of that, you can't compare it to the other model. It's possible to apply a 20-kilometer cable and with the same capacitance and inductance, but it's so much more in detail that a comparison between them, between AC and DC, is not reliable. It's not sensible, and that's why these test cases can't be applied to compare the AC. Yeah. So in this case here, first of all, it was tried to make the model as simple as possible to get rid of some possible failures which can occur due to other components. But even the most basic model can't be run, and it's different approaches has been done on this HVDC transfer, but it's always the same. Always the 200 megawatts go into the rectifier, but nothing comes out, and we weren't able to figure out what is the problem. There was much research on how to do it, but it's not possible. So different. We also we tried in every single direction with every single possible thing, and there are also other things which has to be considered, which has been done. For example, the AC frequency has to be set on constant, that the solver is able to solve it in frequency and time. But as I mentioned, it didn't work. But nevertheless, due to the HVAC simulation, some conclusions can be done. HVAC seems like it's possible for short HVAC for submarine is possible for short distances. We have seen that the depending on the voltage, the reactive power is high or lower, and it also depends on the power which is transferred. So it seems like HVAC for submarine is possible for short distances. This is also mentioned in many literature that for submarine HVAC was applied. But another conclusion is, if you take HVDC or HVAC for submarine, is a multi-fact based decision. It's depending on the power. It's depending on the weight of the cable which will occur. So for HVAC, you need much bigger cables, and they are more heavier. They are not so easy to bring on the ground to handle, and yeah. So it's a multi-fact based decision. But I think the most important conclusion is that the heavy bulk transfer with HVAC leads to problems. As I mentioned, in the reactive power which will occur, and based on the different power, the phase shift can get extremely high. So it seems like heavy bulk transfer can be a problem, and this is also taught in many different literatures and also in our smart grid course. And another important thing is to support the HVDC for submarine is the wind farms tend to be bigger and bigger, and consequently they will be more far away. And so you have a longer distance, you have more power to transfer. This is the reason why HVDC will be more applied in the future, because the farms are more far away, you have bigger capacitance, and you have more power to transfer. If you have a big reactive power, this will be a problem, and you need thicker cables. And yeah, so there is, just based on the HVAC modeling, it is shown that HVDC is it is shown that there is a reason why HVDC is applied to the wind farms. And with that, I close this video, and thank you very much. I wish you a nice Christmas, and see you next year.